Hey everyone, and welcome to Tech Will Save Us podcast. I'm your host, Dr. Tom Helliwell, as Callum's having a day off, and I'm joined today by Gianmarco from the AMRC.
Hello.
Introduce yourself.
Hi Tom, I'm Gianmarco, a tech lead at the AMRC in Sheffield. I'm a tech lead in novel robotics, and sort of my area of interest is any sort of non-conventional robotics. Specifically, I try to look at what research happens in university, and especially all over research in robotics, and how can we apply that to industry. So I try to look at low TRL research that is again very academic based, and I try and see how I can push the research towards the higher TRL spectrum, like 6 to 7, and give that to industry.
Crossing the chasm, as we say.
Yeah.
And joined with Gianmarco is Mark Gray from Universal Robots. Thanks for coming down.
Hi Tom, thanks for having me. So my name is Mark Gray, I'm the Universal Robots UK and Ireland manager. I've just set up our UK office in Sheffield, which is our training hub, and we've got a demo suite there. I've been with the Universal Robots 7 years, which makes me a dinosaur in Universal Robots terms, and I'm here today to tell you a little bit more about what cobots can do.
Fantastic. So today we're going to talk about robotics and the area of robotics, especially around manufacturing and its applications in industry. Where do you think we've been as a human race? What's our relationship been with robots and AI up to press? What's your sense of where we are today and where we should go next? Where do you start, Mark?
So yeah, my take on it is that robots have always been seen as quite negative, I think, in the media and sort of in the press, where people relate them to job losses. But actually technology has always enabled how people are going to do their work and be more efficient. And I think that is changing. There is a sort of global movement to look at automation generally, and robots are now being seen as a good thing. Potentially, like our robots, we make collaborative robots so they can share their workspace with people, and that's opening up new opportunities for people, really.
Yeah, no, I agree just to add on what Mark said. There's always been sort of a mistrust in robots, because the common sort of public sees robots as they're going to take jobs away from us. But that's never the case, especially with collaborative robots, but robots in general. They're there to sort of make life of employees better. So we're trying to remove, or like roboticists in general, trying to remove the physical labor from humans. We're trying to make sure that humans are more comfortable when they do their daily jobs. And we don't want people to think that robots are going to take over their job, because that's never going to happen.
I think from me as well, I think there's robots in software in a way.
Yeah.
When I think about software, some of the work that Racer does and AMRC and everyone else really is that in a way we're seeing robotics in software, automating processes. I think when it comes to robots, classically we think about things that are doing physical tasks. But it seems like the software world is almost automating quicker than the physical world. I think we've seen that happening recently. Things like robotic process automation. So when you do something, you order something online, suddenly it'll trigger a chain reaction of events. And it basically means there's less people required fundamentally.
Yeah.
Whereas robots, I think the robot arms that Universal Robots are now doing, the cobots, I think the thing that people think about are, your car factories, where it's a structured environment and they're just doing body in white, grabbing the big panels, welding, spot welding, assembling the parts together. And I think one of the amazing things with what Universal Robots are doing is the fact that, they've been using environments that you would never imagine a robot to be in. Places where you expect people to have to do it. Well, sanding was one, wasn't it?
Yeah, we've seen them used in really quite small companies, and they take over tasks that traditionally you would have thought that a robot wouldn't do, and it might be sanding garden furniture or assembly of furniture, that sort of thing. Well, very labour intensive, but quite dull tasks, and difficult to recruit people to do those tasks nowadays, and also difficult to retain people. So if you can take that strain away by using a robot to do that, that means that you can deploy the people that you've got. So we're seeing more and more of those kind of smaller companies adopting robotics, rather than the big sort of major users of automation in the past, like you say, have been big car production lines. It's all the sort of smaller manufacturers in different fields that are starting to adopt this technology. And that's what's really exciting, because if we do that domestically, it means that we're sort of competitive on the world stage as other companies that are automating, other countries that are automating as well. So we have an advantage over other companies in sort of Turkey or China in the fact that we're closer to the rest of Europe. So if we can make things for less money, we can export them without the extra logistics cost that China has to get products halfway around the world. So that's a big change for us, I think.
I suppose the labour costs as well in the Western Europe actually supports return on investment.
Exactly.
Which is another reason why you should look at it. But yeah, I do. This concept of automating tasks, I think, is really powerful, because I think there's a sense within manufacturing that you almost need to build a brand new factory and it's got to be completely automated.
Yes.
Whereas, as you say, with the universal robots, thinking what tasks can I actually automate, and actually it just fits quite nicely within an existing, manufacturing system, factory, whatever you want to call it.
Exactly. There are a lot of tasks that previously just wouldn't have been able to be automated that we can. And we talk about a low impact installation where you're not having to change your entire factory floor, because that's unappealing for anybody in manufacturing. You must see this in research where you're introducing robots into a process. They don't want to change the entire manufacturing culture. They just want to automate certain parts of it to try and increase the productivity. So that's where we see a big change in it.
Yeah, and to add on that, you mentioned that small SMEs are sort of starting to implement robots in that sense, but we've had projects with even big companies where they have to use, for example, for aerospace, they have to inspect blades or turbine blades, and they have to spend hours and hours spending that, and they're paid, people doing that paid very well, but after 6 months they get bored because it's such a tedious job. Imagine doing that for 8 hours. We've used robots to sort of replace that, but it's not replace the humans. People don't want to do that job, so that's why we need robotics. And another reason why we need to implement robots is that, as we mentioned before, there's a massive gap in industry and in the manufacturing industry specifically. I was running a sort of workshop in Denmark at the ERF. And I realised there's I think by 2030 there's going to be a gap of 80 million engineers that sort of are missing or will be missing from the job market. We're talking about 2030, and 80% of the work sort of force of 2030 is already working. So we can't replace that by the 20%, can't replace the 80 million people that sort of lacking. So robots is the answer to that.
Yeah.
And they also, the answer, as you mentioned, like sort of third world countries where there's very cheap labour. Obviously, we don't want that to happen here. So robots is the answer. If we want to be competitive with those countries where people are paid $1 a day, obviously we can't do that, but we can do robots to automate those tasks that people don't want to do anyway.
Yeah, Mark, what's the market penetration? Because I think it's something we've talked about before, isn't it?
Yeah.
The UK is lagging behind, really, when it comes to, adopting automation, robots, cobots.
We are traditionally behind the G7 countries. Interestingly, I found 2 graphs about 2 weeks ago, and side by side, the UK was the lowest out of the G7 for productivity, but out of the G7 robot density, we were the least as well. So there is a correlation by having more automation and robotics. This actually means that you're going to get more productivity. It's about having the more efficient machines. Throughout all from the Industrial Revolution, we've seen as we've increased technology, we've managed to produce more at less cost with less waste. And that's what we want to work towards. Everybody wants to work towards that. We're talking, it's interesting, you mentioned about the lack of people that are going to be in the economy by 2030. We're all going to be driving electric vehicles by then. So that manufacturing will have to be done locally, and all those high-tech roles are going to have to be sought. We can't fill those roles now, so automation is going to have to play a part of fulfilling some of those roles in that sector. It's true, isn't it? It's an unescapable fact, really.
Yeah, and I think the sort of systems you're talking about, visual inspection type stuff, where actually the robot concept and the software concept are really starting to come together.
Yeah.
That side of physical systems type stuff that we're familiar with the automatic and systems control engineering department in Sheffield. This idea of cyber physical systems where robot arms, vision systems, software, whatever the newest software architectures are and cloud, all that sort of stuff, are really brought together to do something totally different.
Yeah.
And it's also, I think it's the standardisation, isn't it, of it?
Yeah.
Every single time it does the same inspection.
Yeah.
There's no human error either, so there's a compelling case for it as well.
Yeah, exactly. You're not only reducing like sort of the amount of unpleasant jobs that people don't want to do, but also making sure that that job is done repeatedly, because that's what robots are good at. They're very repeatable. If they do one task once, they're going to do pretty much the same thing forever. So yeah.
Yeah, I think Mark mentioned automate what you hate. That was your statement.
Yes.
So what sort of things are you seeing? What are people hating and automating?
So if you've got any sort of material removal, whether it's sanding or deburring or grinding, and grinding is interesting because the vibration white finger statistics show that it's actually, you can't use a grinder for 8 hours a day. There are only a certain amount of time limit that you've got. And the regulations are going to change in the future where it's going to become more stringent. So people are going to have to look at another method of doing this or employ more people to do it. But one of the anecdotes that we get told more and more when we speak to people who are doing these kind of tasks, they just don't want to do them. You know, you can't put somebody on a job for more than 2 weeks before somebody else has to have a go of it because they'll just leave.
Yeah,
So,
I mean, I've seen the opposite. I've seen a tier 1 aerospace supplier. You've got like 8 guys leaning over as part of an airplane wing who won't give anything more away, but they're stood there standing away with aluminium. Some of them have got masks on, some don't.
Mm-hmm.
I think this is crazy. For such a modern, incredible product they're creating, the manufacture process was just almost really far behind.
I think because we've got a labour gap in the UK and we've got an ageing population of workers that have got skills, we've started to change how we look at people, and we really value people. Like, human skills are the biggest asset that any manufacturing business can have, but also you want to look after their well-being because you want to retain people. So if you want to take away those horrible chat tasks they don't want to do, that's when we should automate them, really. And that's, I think robots and technology is a good way of sort of fixing that problem, really.
Yeah, and another trend I'm actually seeing is talking about like terrible jobs that no one wants to do, is sorting waste or picking up and recycling waste. Something terrible. They don't want to do it. Again, third world countries, there are people doing it, like spending loads of it with no safety on and not paid much. I can see that I've been sort of in contact with some companies, local companies, who want to do it here, but also they want to do it safely and they want to do it properly so people don't get injured, and they're looking at using robots. And by using robots, you also remove the sort of necessity for hazmat suits, because you don't know, in some companies at the moment, the employees will have to wear for 8 hours a full hazmat suit because you might be touching something that's contaminant. So if you use robots instead, you don't have to use it. And same thing when it comes to nuclear inspection. There's a lot of robots that I use at the moment because you don't want humans around there.
No.
And then robots are much safer around them instead.
Yeah, I think it's getting those guys who maybe would be doing that work and doing something what you class as higher value.
Yes.
Higher value activities.
Yeah.
Things that, you know, humans are really good at and robots are not very good at. And even all this AI that we're now getting excited about can't do.
Yeah.
You mentioned problem solving, things like that, things that, you know, they just struggle with.
Yeah. Yeah, that's why you can't really get rid of humans, really, because humans are always going to be behind the scenes, controlling the robot, like training the robot, making sure the robot does the right thing, because sort of problem solving skills that we've got, robots probably will never be able to do. And you mentioned software. Software is going very fast now, and hardware is really is trying to catch up when it comes to robots. They're very hard systems. You've got like you need to know about electrical. So engineering needs to know a bit of control, a bit of mechanical, a bit of software. And then if you talk about like ChatGPT or whatever, yes, you can integrate that with the software of the robot, but then the robot will be able to understand your command, but then how do you translate that into a motion of the robot? Because doing that specific thing, like, I don't know, picking up an object, to a robot is quite complex because you can pick up an object in 1 million different ways. So how do you choose which one? It's very hard to sort of catch up with software.
think we've seen that with Universal Robots and some of the businesses around robots. They've really made the barrier to entry a much lower. I mean, Universal, you guys have got some amazing software where you can literally train it by guiding it through a path, can't you? And you've got an ecosystem around the end effectors and
it makes it just easier to deploy. I mean, that's the whole point of our offering really, is to have a pathway to make it as simple as possible for companies to buy a piece of equipment, put accessories with it that are going to tried and tested, that will work, and they can get results from quickly. Because that's one of the things that's really important to small companies, is that they don't want to put something in and spend 2 years developing it. It needs to be within sort of like a matter of weeks, and then they're saving money and they've solved that problem. So by making it easy and simple for people, that's the sort of mainstay of what our business philosophy is all about, really.
And I have to say, as a sort of user, I really like what Universal does, because I'm also sort of working on collaborative workspace in general, and we look at the sort of psychology of robotics and what the attitude towards robots are from humans. And sort of research shows that sort of trust and understanding of our technology go hand in hand. So the easier you make something that is novel, the more people are going to accept it. And you guys at Universal, they probably have got one of the most sort of intuitive sort of robotic system to use, and even the interfaces, they're very simple to use, which we use all the time.
So you're working on collaborative workspaces. So this is this concept of humans literally working side by side with cobots. Okay.
Which is really interesting, because that's one of the areas where you can increase productivity massively by blending task balancing between a human and a robot working together. That's where the traditional sort of thought process is it's either a person or a robot, but having both together means that you can produce so much more, and let the robot take over the things that it's good at and let the human carry on doing what they're really good at. That's where we see the sort of main growth in robotics over the next 5 to 10 years.
Yeah, so I was going to say the economic benefit is almost immediate, because if you just think about it, if you have conventional industrial robots, they need to be in a cage within barriers. But if you sort of merge the workspaces, you can have the robot and the human work in the same space. You don't need space. You don't need as much space. You need as big as a factory. You can just reduce space, and that's already a massive increase in sort of reducing in costs.
Yeah, I think the first thing I start thinking about is kitchens. I've been spent a bit of time as a chef, and I think the idea of having a robot arm cutting and maybe peeling vegetables or something, quite compelling. But surely there's some safety challenges around that, and I know that cobots have a lot of safety systems in place. But if a robot was holding a knife, did you mention there's some research going on in that area in order to sort of manage that type of situation potentially?
Yeah, I think I would say we're quite far from having a robot in the kitchen yet. Mostly because, as you say, as soon as you give a robot sort of a knife in his hand, if you lose control of that robot, it can just cut someone. Because, as obviously Marco can tell us, especially collaborative robots, they've got sort of 4 sensors at each joint, so they can sense a collision at any point. They can just stop. But if you've got a sharp knife, even when you're touching someone's eye, you don't need that much force. You can still harm someone. So the research that is sort of happening now is it's not just focused on the robot works, but it also looks around humans. They look at human tracking technology, or even looking at the human if he's getting closer to the robot, if he's like keeping his distance. That shows that if the human is keeping some distance, maybe there's something going wrong, so the robot can be slowed down. And there's also obviously lots of AI just to understand facial emotions or people's response to the robot, and so again tracking of the person, and that's gonna again is a work in progress, but people are looking at incorporating that sort of AI algorithm to understand the sort of human behaviors into the robot controller, so we can have a more comprehensive understanding of the environment, which includes the human as well.
Yeah, I understand. Yeah, because I think Universal Robots, it has some mechanism for when it touches something. It touches something, it has some sort of mechanical.
Yeah, we've got force monitoring throughout all the joints. So if the robot collides with somebody, it detects that and then it puts itself into a stop. But if you've got something that potentially could injure somebody on the end, like a rotating tool or a screwdriver or something, you can protect the person from an area scanner. So if they go into the zone, you can make the robot stop, and we call that speed and separation. It's interesting what you were saying about that dynamic, being able to monitor a human's behaviour and then adapt the robot's program to that, because that is the future. That is where you've got a complete collaborative cell, and the flexibility of that, of course, means that you can make many different types of products in that one type of cell, and having that dynamic link to the human, it can interpret what the human's going to do next, so it can set up the next part of the process and so on. So it's a really interesting research area, I think, that.
Yeah, there's also some research that's looking at sort of monitoring the human behavior and see if the human there's a change in this behavior. That means that maybe the person is tired, so the robot should adapt to that tiredness and making sure that it can go the same sort of, it can synchronize with the human, it can just slow down so the human doesn't get tired. Also, because we're talking robots are here not to replace jobs but to make jobs easier. So there's some research that's looking into monitoring the person, and for example, in attending exercise, when there's a robot and a human sharing a workspace, when they pass objects to each other. There's lots of research looking at the sort of most comfortable way for the human to pick up the object and give it to the robot, and then the robot sort of optimizes looking at the height or the posture, and then it can just tend the object in a much better way, so the human posture is better and you don't have to sort of bend because in the long term, if you do that for 8 hours, that's very detrimental to your.
So is it doing some sort of real-time control type stuff like that, rather than just running a program over?
Yeah, it's a real-time control which is sort of connected to also our human tracking, and with some at the moment they do it with sort of IMU sensors and also some biosensors where you can just track sort of heart monitor of the person, or even like the posture if that person is sort of bending a bit too much. Because even when you work on a monitor, you're supposed to look at the monitor at a certain height, because for 8 hours a day, every day, you might start sort of causing pains to your back or to your spine. And we're trying to, people in research are looking at that same exact thing, but with robots. How we can make sure that this collaboration is as efficient and as healthy for the human as well.
And that's important, because you could have different people working in that same cell.
Yeah.
So you could have a lady who's 5'6", who's weighs about 7 or 8 stone, as a guy who's 6'4" and weighs 20 stone. How their posture and how they're going to interact with the cell is completely different. The ergonomics will need to change dynamically.
So that research, does that take place primarily within universities now, or is the industry taking the lead on that sort of thing? I think as well, the other question I was going to ask, just part of that is, where does the robot operating system fit in with all this sort of stuff?
Yeah.
Because that's been going on for a long time. I know it's been developed by universities all around the world for a while, but where does that fit in with this whole ecosystem we're seeing now?
Yeah. So from what I've seen, and I'm looking at roadmap in the sort of collaborative workspaces for the AMRC in general, but also for the UK industry. Unfortunately, it's mostly academia. There's not industry in a sense. They're looking at sort of this aspect, but they're just putting the funding in, and they're not getting involved as much. The trend is changing. More industry are understanding that that's where we need to go, but it's mostly academia, and that's another thing that another trend that you see with ROS, the robot operating system, which I'm a big fan of, but again, is not really implemented with industry. And just for the people watching us, ROS is this middleware that's been developed to sort of unify and make it universal how you control robots, because many robot brands have got their own proprietary language and they use different ecosystem to control themselves. And then when you're trying to build a cell, especially people like us integrators, where you've got different systems working together, everyone uses his own proprietary language, the integration takes ages. And ROS was born just to sort of tackle that, to make sure that every sensor, every actuator, every robot shares the same language and you can talk together. The problem with that is ROS is very, again, academic, because it's open source. And which open source is sort of its greatest strength, because it's open to everyone, and research you can just reapply to other tasks. So you don't have to start from scratch, you can just implement whatever people have done already. But then that open source is also the biggest weakness as well, because people like aerospace companies, they can't really trust
No.
it because you don't know.
Yeah,
The barrier to entry.
security is a big issue.
Yeah,
You know,
barrier
if
to
in
entry is
laboratories
quite high.
and you know, high-tech manufacturing, secure manufacturing, they want to have something that's secure and has traceability in it as well.
Yeah.
So Universe Robots have spent a lot of money and time and effort on their software because it's just the barrier to entry is so much lower.
Yes.
Get a robot in, train it in the way you want to,
We
integrate with it.
Yeah, we wanted to create something. And what's interesting about where we started from, we actually, before we were a robot company, the three guys who started the company actually did a research project to ask people why they wouldn't use industrial robots. And the answers they gave formed the nucleus of what a cobot was. They decided to make the architecture to have force monitoring so it didn't have guards around it. But they wrote a software package called Polyscope to make it simple for non-robot programmers to use it. So they could have released it just with ROS and the uptake might not have been as quick. But by making it really simple for people to use, because we didn't have anything previously, we weren't an industrial robot company that's adapted a product, it's been created from scratch. So that's one thing for development of products is when you actually go to the market before you've made the product and say, look, what do you need? And they say this, and we come back with the package to say, look, now we've made this, it is easier to use. And that's the thing. The ROS, we have a ROS driver package that we have for ROS and ROS 2, which is really useful for researchers and so on like that. It's like, well, essentially like a plumbing system that messages go in between all the different parts of the robot and different systems. But we wanted to make something that was out of the box ready that anybody could simply use, whether you're in a machine shop or whether you're a welder or whether you're in a food and packaging company. They can all use that software we've created straight out of the box, and we keep adding bits to it with other templates and wizards to try and make it easier. It's a bit like the old paperclip you used to see on the Microsoft Word, is the things that it gives you hints and tips and things that you can't do wrong, but it actually just makes it easier for you to use that piece of software rather than just giving you a manual and saying there you go. It's that's the way that we try and make it as simple as we can.
I'll say it's a bit better than that because
Yes, I got really annoyed that paperclip, didn't it?
Yeah, what do you think the future will be of robots? You really see them more frequently out there in the wild and in manufacturing systems. Do you think there will be a platform, a standard that emerges as being the one that everyone has, or do you think it will stay sort of quite mixed?
I think it's quite fractured, isn't it? At the moment, there's lots of different manufacturers in different fields of robotics. I put a poll on LinkedIn about a week ago and put sort of 4 different examples of areas where people are interested in robotics being used, and by far the winner over anybody else was agriculture. A very labour-intensive sort of industry, and again we're facing that where we can't get labour to come into the country to help us, and agriculture is the backbone of any economy. You've got to feed yourself domestically, so that's one of the areas that people are really interested in developing robotic systems for, I think. There are others that are quite labour-intensive, like construction and logistics and just general sort of like other sectors that we still rely on human labour for, but agriculture was one that was really, really strongly in that. And I think that's going to be a big area for investment over the next 10 years, I think, where people are going to need to sort of develop robot systems.
It's interesting because I think agriculture's it's like robots in the wild, quite literally in that case. And then with logistics, it's again similar. If they're going down the street, I know that in America they've had a few of those sort of delivery robots kicking around. And also you can have automated cars and things like that. But then you look at an Amazon warehouse and they have robots, but it's a very self-contained environment.
Yes.
I think with manufacturing, we are seeing a lot of challenges with interoperability, getting data across from CNC machines, robot arms, conveyor belts, whatever it is.
Yes.
It's been a big challenge. And I think there's definitely a lot of demand for something that maybe grease the wheels of that data and interconnectivity and control that we don't seem to have right now. So
I think
it's
so.
an interesting area.
And again, that's I think what ROS is sort of the answer to, because that's why ROS was born for, was just meant to be an interoperable sort of system that can communicate with everything, and again, sensors, actuators, robots, and I think there's sort of a sense that industry is getting more interested in it, in ROS specifically, and maybe we're gonna take a bit take on sort of not necessarily away from open source, but a more rigorous open source that's more structured. because I think just at the end of last year, Open Robotics, which is the company that was looking after sort of the ROS maintenance, has been purchased by or has been acquired by Intrinsic Robotics. And Intrinsic is sort of a subdivision of Alphabet, which is obviously the company that owns Google. So you can see that people like work there in Google or whatever, they can see a future in ROS, because they can see, as you say, there is this need of a common language for system, because as the complexity increases, we need to make at least the basics simpler, because the task to solve is actually so complex in itself. So if we just spend years just making sure everything communicates with each other, then we haven't solved the task yet. We're not going anywhere.
Yeah, I can see that. Yeah, I think as well. Like, I think a lot of people see robotics as, they think of the humanoid robots. I was going to ask you about this as well. Like, who do you think's leading in terms of robotic excellence in the world now? When you think about humanoid robots, I know Boston Dynamics is like the one that always comes up in my mind, but I know Tesla is investing money into it now. Is there any others that sort of come to mind about
I would say
pushing
definitely
envelope sort of thing?
Yeah, I would say Tesla's definitely not leading. There's a few, I can see in the past actually few months, I've seen a couple that have been popping up. I can't
necessarily Chinese ones, isn't it?
Yeah, Chinese companies, I don't necessarily remember the name, but I can see loads of coming up. To be honest, I find them extremely cool. I don't understand, because having a robot arm like you are on top of a wheel, sort of AGV, that's all you need.
Yeah, it achieves a similar goal.
You don't need that level of complexity to run sort of a humanoid robot. It's ridiculous. We've got just like the gate, just walking is completely complex, and if you need to add weights on it, and you're spending loads of money to have so many degrees of freedom that are necessary. If you just have some wheeled robot, they can just, with an arm or a couple of arms, you've achieved what you need to do. So I don't really understand why we're going towards that road, hence because I don't need
I guess they're trying to aim for this like completely generalised platform, aren't they? But it's certainly a big ambition.
But definitely. As with AI, every time, or AI or in general, and even with my experience, I realised that every time you try and make a product that is general, that tries and do everything, it's just bad at everything. While robotics, you just need to sort of decide on the task you want to do, and you can do that task amazingly. I understand that some sort of flexibility does needed, because tasks like the product that's coming, the object that's coming, you need to pick up, might not come always in the same orientation, or might not. I mean, every single task is already quite complex on its own, so we just need to make sure that we're very good at task-based projects, rather than let's try and make everything, because we can't.
I think you touched on a good way of thinking about it. So I guess, Mark, when you go to a manufacturing business, do you support them on identifying which tasks they should target? And how do you go about doing that then?
We actually did that yesterday. We were out over in a company in Oldham, and basically it's almost like doing an audit on their production lines, and you can rank them through 1 through to 5, of easy right through to very difficult. And difficult can involve, there might be multiple parts that have all got to be fed and organised before they're being assembled, as opposed to a part that's just going into a press or having one screw inserted into it. So we always try and steer people towards using the easy one first, because the culture of implementing a robot arm into a company is get one in first, let's show it's successful, let everybody see it and get comfortable to be around it, and then that sort of changes the culture and their output on things where it's taken over a task that perhaps they didn't want to do, and it's making more profit for the company, which means they're more sustainable. So we do help with that. We go and do these audits on company sites to say this is easy, this is not, and then sometimes we find things that we've never done before. They could be really quite complicated, and we'll do an evaluation on that and see whether it's possible or not. That's the best way, really. Is you'd want to help everybody, but there are some tasks that are still, they look relatively simple. Humans are amazing. We were talking about the humanoid robot there. A human to be replaced by a humanoid robot is really difficult to do, because we've got our own built battery. We just feed ourselves and that provides energy. We've got wrists, fingers, joints, eyes, and a brain that can make all this decision. And to automate all that would be incredibly complicated to compete with a person.
Yeah.
So we're nowhere near.
I suppose as well we've created this environment in our vision of ourselves. So to some extent, I suppose we've made that bet, you know.
Yeah.
Because if environments were built purely for robot systems,
Everything would be flat.
you could.
I mean, Daleks go
loads of
upstairs, can't they?
different
So
ways
everything would be
you
flat.
could organise it better for sure. Yeah, it's just taking me back to the Amazon warehouses again, where there's just no people. The basic shelves in robots with a shelf on top, and they all just sort of bring the shelf to you, and you grab it out, and it disappears back into the crowd.
Yes.
And there's no humans in that area. That is just purely, I don't know what it's kind of like a dynamic shelving system.
Yeah, like a hive or something.
Yeah.
It all comes down to cost per pick. So the more times a human has picked that product and put it down on something else, it's adding to the cost of the logistics of getting that product to the person. But the less people that touch it means that it's less expensive to produce and get out there into the marketplace. So automated warehouses and logistics is something that is going to increase. You know, almost everybody uses online shopping for one thing or another, for Amazon or for going to a place like Ocado for your shopping. All these sort of have got automated systems behind them, and that will increase because it has to reduce costs. So for the future, that is going to see something we're going to see increase.
I think as well with that type of implementation, it's relatively easy to see the return on investment again, isn't it? Because one of the frustrations that we have in Raise was we're trying to sell data management things, and I'm trying to say, think about the continuous improvement abilities. If you've got the data in one place, you know what your company's doing, you can take action on it and become better. Whereas if it's automating something, whether it's software automation or it's automating a task, it makes it a lot easier to sort of make that business case to invest in it as well.
Exactly. You've got to measure something to know how the process is improved first, haven't you?
Yeah, exactly.
And if you can show that in data sometimes where something's paid for itself, and after it's paid for itself, it's then earning money for the business, that's quite a compelling thing to look for further tasks that you can automate, really.
Is there anything else at the AMRC that's going on in terms of research in robots and automation that they think is worth mentioning or discussing?
We do touch on very broad we try and look at the whole aspect of robotics. One thing that I think has been mentioned before that we're looking at is reconfigurability, so having reconfigurable cells where you can just sort of swap the robot and almost like nothing has happened. You don't have to spend days or weeks rejigging and doing the integration again.
There's just one that occurred to me just as you were speaking, which was the robotic machining that's been going on for quite some time at the MRC. Yeah. Now, the gist of it, correct me if I'm wrong, is it for large geometry, basically roughing based machining?
Yes. So the advantage of robots compared to like conventional CNC machines is that you've got a much bigger workspace, and you can, and also you've got more flexibility when it comes to if you want to do different shapes or different sizes, you can just reprogram the robot. You don't have to rebuild home, because those CNC machines are quite specific and they're very expensive as well. Robots can be much cheaper. So when it comes to machining, if you can have a robot doing it, you've got bigger environment they can work with, and you can just reprogram it, and it's much easier and much cheaper. But you've got the disadvantage of robots, especially serial robots, where they're not as stiff as CNC machines, so you get a bit of drop in accuracy. Because again, as we said, robots are very repeatable, but they're not super accurate compared to CNC machines. So there's always a trade-off. One of the solution we found is, I don't know if you've been to our centre, where we've got massive robot Titan, which is like enormous. I think it's got 7 meters of working volume. But then it's a massive robot. So it's quite funny to watch him because it's got a tiny spindle just to do like very precise machining, and then you've got this huge machine that's like probably 10 meters tall.
Is there a challenge with the stiffness of it as well? Cutting something that's really
obviously it's much, because we've got a bigger mass, obviously it's much more stiff than like conventional robots, but it's still not as stiff as a CNC machine. So
that's very interesting. I think it's when I heard about it for roughing operations, it made a huge amount of sense, to be fair.
The AMRC is an absolute jewel for South Yorkshire, I think, to be based here, and that's one of the main reasons why we came to Sheffield. We wanted to be based here. Our UK head office is here, and we see Sheffield sort of evolving as a technical hub, really. You know, for having innovation led by the AMRC and the universities here. That's why we wanted to be aligned here to sort of create a cluster. Because Sheffield's always been a maker city, hasn't it? It's been one of those places where innovation has started, and there's no reason why we can't do that now. Create the next sort of skill sets that people are going to be able to use, and smart manufacturing that people can use can originate here, really.
Yeah, I think it's obviously one of the birthplaces of the first industrial revolution, you know, and it'd be great to sort of take more control of the fourth industrial revolution, create an ecosystem, really, I think. Where do you think we're going wrong? It's a classic question.
I think, well, there are no fundamental reasons why we're going wrong. Is that we need to sort of change our perception of manufacturing, really, in the UK. It adds real value to our economy, and what we export, we punch above our weight with the sort of GDP that we have. We export a lot, and it brings a lot into our economy for that. But we need to sort of make it easy for people to gain those skills, to make it easy for companies to use technology to be competitive on the world stage. We were in the past. When you look at the Victorian era, when we went through all the sort of industrial revolution, the things that we developed, you know, anything that I'm reading a book at the moment called Exactly by Simon Winchester. It's the history of precision. Precision engineering started in the UK. Up until that point, people were making bolts with all sorts of different types of threads, and we standardised on it, like we did with the time, Greenwich Mean Time. It's a world standard that originated here. There's no reason why we can't get back to that sort of mindset and make engineering really interesting for people, and be able to set the standard and domestically produce products that'll expand what we export abroad, I think.
Yeah, no, I agree with that. I think education is the key. We need to train more people. As we said throughout the podcast, there's a massive skill gap that we need to sort of address, and the only way to do it is if we just sort of tackle this by teaching new people, training new people. And it's not necessarily with university. Certain jobs you don't need a degree, you don't need a PhD, you just need to be trained and, you know, an apprentice to just do the work. So yeah, just like training and disseminating how much how interesting robotics is and how much you can achieve and how great career it is. Because sometimes I can see that people are sort of poached from finance, people with the skills that we can sort of that can be used for robotics or engineering, and in general they're just poached by like big company, like finance companies, because they can pay loads of money. But then at the end they don't really enjoy the job because it's just crunching numbers. They're not working with robots and not seeing the future in there.
I think there's a bit of a disconnect as well with engineering being able to communicate with people who are in finance to get funding. And I always said in the past that maybe people in accountancy qualifications should do one module of engineering, and people in engineering should do one module in accountancy, and they can find some common language where they can discuss about return on investments, why we need to invest in this, what it will bring to us, because they don't really understand each other, I don't think. And once we sort of break that cycle, then that's when it's going to be successful for people to get money from above and invest in the shop floor, really.
Yeah, I think it goes from just the average business through to venture capitalism and all that sort of stuff, because the ecosystem just isn't anywhere near as mature as it needs to be. I think the other things we could do with more end user businesses. Someone selling a great product, you know, like the only one that's coming to mind is Rolls-Royce, but it's because there's only 2 companies in the world that make, you know, engines of that type, and we need more of those sort of businesses, I think, because we do have a lot of businesses in the UK supply chain, but we haven't got so many that are selling the end product.
Yes.
I think we need more of those.
And that's where the real value is added, is when you've put something together and you can export it all over the world. Yeah. That's where the real sort of like future lies, I think, for our manufacturing.
I think we should, one thing that we can lead on is like the sustainability aspect of manufacturing, because the UK has always been, or in recent years, I think we're striving for better sort of sustainable manufacturing. And that's one thing that we can lead on and sort of teach the rest of the world, because there's a big argument that I hear often that the UK only produces like 1% of the total CO2 emissions, so it's not even worth doing it, because if the other countries don't do it, we're not going to make a difference. But well, it's not true, because first of all, we was given an example in manufacturing, and we can just lead the way and teach other people how to do it. But I was reading this article the other day, and apparently, obviously, 1/3 of the sort of gas emissions are produced by China, but I think another 1/3 is small. Lots of small countries like the UK that produce 1%. So if everyone has the same sort of attitude, oh, it's only 1%, still 1/3 of the
Nothing will change,
nothing will
yeah.
change. So I think that's another thing that we should learn. And so when we start looking at robotics, we should think how we can use robotic system to sort of make it more sustainable manufacturing. For example, I've seen lots of research using robots for disassembly. So we've got a part of any system, especially electronic system, like just like chucked as a whole, because they can't be used, because we need to sort of rethink the way we create manufacture, because at the moment manufacture is not created for disassembly. We just create something to be used once and then chucked in the bin. We need to first think about how we can create for disassembly, but also how can we use robotics to sort of inspect a part, take it apart, and then disassemble it, and then reuse what we can.
Yeah, you can imagine almost like a standard that maybe supports the disassembly and like a circular economy type thing.
Yeah, exactly.
And it almost has like signposting for robotic systems to disassemble it and then organise all of the constituent parts or whatever.
Or bills of material, knowing what materials in that sort of specific device and where everything goes. Yeah,
that'd be a really good idea actually. Yeah. Is there anything else on sustainability where you can see it being applied?
Like robotics in general.
Yeah, robotics and manufacturing. How could the
robots
UK lead it?
they don't make as much scrap as humans do. They're more repeatable. So it staggers me when we go and see companies, how some of them run at quite considerable scrap rates and just consider that as part of their operations. But there are ways of automating, some of the tasks out to make it that you make much less scrap. And now with energy at the cost it is, it's so terrible to get all the way to a final part of an assembly and then it turns into scrap. You've added value all the way through and time, but automation and robotics is one way of being able to make products better for less. And it's true about being like green and using sort of lean manufacturing principles to do away with waste. We are incredibly wasteful in manufacturing and we need to automate out of that really.
Yeah, it's a very good point. I think the standardisation of things in automation, it does really help with quality issues because there's just less variation in the process, so you just don't get as much quality issues.
Exactly.
I think there's definitely a bit of a misunderstanding almost about quality and how important it is. When you talk about big volumes of things as well, you're producing millions and millions of things. Even 1 in a million starts to get problematic, and you could have a whole marketing issue, the brand issue if something really went wrong. The company value, brand image could change very quickly if it's out there and fails.
So if you aim for the best quality ever, it kind of solves the problem of having any scrap anyway.
Yeah.
So all companies should steer towards that, shouldn't they, to try and adopt the best quality processes, the best manufacturing processes they can, so they don't make any waste.
Great. Well, guys, thanks for coming down. It's been an absolute pleasure to have you here.
Thank you.
Same, yeah, it's been a pleasure.
And thank you guys for joining us today.